Hey guys, and welcome back to another video. Today we will be preparing some potassium cyanide, which will be used to produce some potassium ferrocyanide for making blueprints in a future project. As a quick warning, cyanide compounds are extremely deadly. As little as 1/3 of a gram of potassium cyanide will kill you in a few minutes. Do not attempt this at home. This video is strictly for educational purposes. To start the synthesis, we will only need some charcoal, urea, and potassium hydroxide. Sodium hydroxide can be substituted if sodium cyanide is the desired product. I demonstrate how to prepare potassium hydroxide in a previous video, and the urea was obtained from fertilizer. It can also be found in some instant cold packs. 25 grams of potassium hydroxide, 23.3 grams of urea, and 10 grams of charcoal were ground in a blender and added to a steel can and placed on a stove. As the mixture is heated and reacts, first the urea decomposes to isocyanic acid and ammonia around 160 degrees Celsius. Ammonia gas is toxic, so this step must be performed outside. The isocyanic acid then reacts with potassium hydroxide to produce tripotassium cyanurate and water. Further heating breaks the tripotassium cyanurate into potassium cyanate, which is then reduced by carbon to form the final potassium cyanide. The mixture was heated to around 600 degrees Celsius to ensure a complete reaction occurred. As a side note, a stoichiometric excess of potassium hydroxide was used as the carbon dioxide produced will react with some of the potassium hydroxide to produce potassium carbonate. An excess of charcoal was also used to ensure the cyanate is completely reduced to the cyanide. The mixture was heated until all bubbling ceased, and then it was allowed to cool. At this point, the mixture contains highly toxic cyanide, so extreme caution must be used. The remaining chemistry was performed in a plastic tote in case of spills. To start processing the cyanide, the can was filled completely with methanol. Methanol can be purchased as methyl hydrate from hardware stores. The beaker was left overnight so everything could dissolve, and then the material was carefully transferred into a 1-liter beaker. To check for the presence of cyanide ions, a few drops of methanol solution can be added to a solution containing iron 2 and iron 3 ions. Prussian blue pigment was immediately formed, confirming the presence of cyanide. To destroy residual potassium hydroxide in the methanol solution, an excess of sodium bicarbonate was added. This forms sodium and potassium carbonate, which is insoluble in methanol and precipitates out. It is important to destroy the potassium hydroxide with a base, such as sodium bicarbonate, and not with an acid, as a strong acid will react with potassium cyanide in the solution, forming an extremely dangerous hydrogen cyanide gas. After the sodium bicarbonate was added, the solution was gravity filtered to remove all insoluble impurities. The final solution should now only contain potassium cyanide. The methanol was evaporated into a dish over a day or so to give some nice potassium cyanide powder. In total, 3.08 grams of potassium cyanide was obtained, corresponding to a 12.3% yield based on the starting urea. This poor yield is likely because the reaction products were not broken into a powder prior to dissolution in methanol. I wanted to avoid this, however, because grinding cyanide in a blender scares me. In the future, I think I will try cycling solvent over the reaction products using a Soxhlet extractor to better recover the cyanide produced. Anyhow, I hope you guys enjoyed this video, and I'll see you in a future project. Okay, bye.